अच्छा, हम लोगों ने इसको देखना है, ये चैप्टर इम्पल्स या मोमेंटम। तो मोमेंटम को बेसिकली हम लोग कंसिडर करते हैं कि मोमेंटम इज द क्वांटिटी पोजेस्ड बाय एनी मास ड्यू टू इट्स मोशन, राइट। मतलब कोई भी बॉडी जब आपका मूव करता है तो देन इट्स मोशन ड्यू टू इट्स स्पीड, या आप यूं समझ सकते हो कि इट्स टोटल इम्पैक्ट ड्यू टू मास एंड, ठीक है। तो हम लोग मैथमेटिकली ये कहते हैं इज द प्रोडक्ट ऑफ मास एंड वेलोसिटी, द प्रोडक्ट ऑफ मास एंड वेलोसिटी। तो आप लोग जब एग्जाम में लिखोगे तो आपने क्या करना है, इट इज द प्रोडक्ट ऑफ मास एंड वेलोसिटी। सो इसका इक्वेशन याद रखना है, P इज इक्वल टू mv। इसका जो यूनिट होगा वो kg मीटर पर सेकंड है, क्योंकि मास का यूनिट kg है और वेलोसिटी का यूनिट मीटर पर सेकंड है, और ये आपके पास एक वेक्टर क्वांटिटी है, ठीक है। अब ये क्योंकि वेक्टर है तो इसकी जो डायरेक्शन होगी वो वही होगी डायरेक्शन जो वेलोसिटी की है, तो इट्स डायरेक्शन इज द डायरेक्शन ऑफ वेलोसिटी, ठीक है। मैंने बोल्ड किया हुआ है सारे का सारा, जो चीज़ें हमारी अलग अलग हैं, जो हमारी रिक्वायरमेंट है वो मैंने सेपरेट किए हैं। अच्छा, उसके बाद हमारे पास आ जाता है मोमेंटम आपका मास डिपेंडेंट है, वेलोसिटी डिपेंडेंट है। तो इस पे पूरे पैराग्राफ में मैं एक्चुअली ये समझा रहा हूँ कि आप मास बढ़ा दो या वेलोसिटी बढ़ा दो तो मोमेंटम वुड बी चेंज। फॉर एग्जांपल आपका 5000 kg का बॉडी है, 6 मीटर पर सेकंड की स्पीड पे जा रहा है, ठीक है। उसका मोमेंटम 2000 kg वाले बॉडी से ज्यादा होगा जिसकी स्पीड 6 मीटर है। तो इससे इस एग्जांपल में मैंने ये समझाया है कि इफ यू हैव मोर मास यू विल हैव मोर मोमेंटम, ठीक है। इफ यू हैव मोर मास वी हैव मोर मोमेंटम। लेकिन अगर इसके बाद मैंने आगे वाली एग्जांपल में ये समझाया है, ये आगे वाली जो स्टेटमेंट है उसमें मैंने ये समझाने की कोशिश की है कि लेकिन अगर आपका जो 2000 kg वाला बॉडी है वो 20 मीटर पर सेकंड की स्पीड से चलना शुरू कर देगा तो इट्स मोमेंटम वुड बी ग्रेटर देन दैट ऑफ दिस वन, ठीक है। तो आपको ये याद रखना है कि मोमेंटम सिर्फ स्पीड की वजह से ही नहीं बनता या मास की वजह से ही नहीं बनता, बिकॉज दैट इज कम्बिनेशन ऑफ बोथ ऑफ दिस। तो इसलिए आपने इसको दोनों को कंसिडर करना है। फिर हमारे पास एक बहुत ही इंपॉर्टेंट टॉपिक आ जाता है चेंज इन मोमेंटम का। किसका आ जाता है?
चेंज इन मोमेंटम।
चेंज इन मोमेंटम। अब चेंज इन मोमेंटम के जितने क्वेश्चन आप लोगों के पास चेंज इन मोमेंटम के प्रॉब्लम्स करते हैं ना, इतने आपके मोमेंटम के नहीं करते। तो चेंज इन मोमेंटम इज बेसिकली कॉल्ड योर इम्पल्स। एक्चुअली अब हम लोग इम्पल्स पे पहुंचे हैं कि व्हाट डज इट मीन बाय चेंज इन मोमेंटम। इट इज कॉल्ड इम्पल्स। तो मोमेंटम आपका मास की वजह से तो चेंज होता नहीं है, मोमेंटम आपका किसकी वजह से चेंज होता है? वेलोसिटी की वजह से चेंज होता है। तो वेलोसिटी इज अ वेक्टर क्वांटिटी, दैट्स व्हाई व्हेन वी कंसीडर इट के velocity, when an object is moving towards right, so velocity is positive, and when an object is moving towards left its velocity is taken as negative. तो आपने ये याद रखना है कि momentum is actually a sort of mean vector quantity. तो in this direction momentum will be taken as positive and in this direction momentum will be taken as negative.
नेगेटिव।
तो जब आपके पास मोमेंटम चेंज होता है तो बहुत ही इंपॉर्टेंट चीज आपने याद रखनी है कि मोमेंटम चेंज मींस डायरेक्शन इज रिवर्स, देन मोमेंटम विल आल्सो बी चेंज। आपका मोमेंटम, अगर आपका बॉडी का डायरेक्शन रिवर्स हो रहा है तो तब भी आपका क्या होगा? मोमेंटम चेंज होगा। एज द डायरेक्शन इज नॉट रिवर्स, सो द चेंज इन मोमेंटम इज कंसिडर्ड बाय दिस वे। फॉर एग्जांपल, आपके पास बॉडी का मोमेंट, बॉडी की डायरेक्शन रिवर्स नहीं हो रही। इनिशियली द बॉडी हैज मास m and its initial velocity is u. Now body has mass m and its final velocity is v. So what is the change in momentum? Momentum change is mv minus mu. What is change in momentum? mv minus mu. तो आप ये कह सकते हैं कि एक्चुअली द इम्पल्स ऑफ द बॉडी इज mv minus mu. What is impulse then? mv minus mu. ये इम्पल्स का फॉर्मूला याद रखना, इट इज इक्वेशन नंबर 1 फॉर इम्पल्स, बहुत इंपॉर्टेंट है। लेट्स से इफ आई से कि बॉडी का मास लेट्स से यहाँ पे 5 kg था एंड इट वाज मूविंग विद द स्पीड ऑफ 2 मीटर पर सेकंड, ओके, एंड नाउ फाइनली इट्स मास डज नॉट चेंज। तो आपके पास मास इज 5 kg बट इट्स वेलोसिटी बिकम 6 मीटर पर सेकंड। तो आपके पास मोमेंटम चेंज क्या हो गया? इट इज 10 and this one is 30. So change in momentum would be 30 minus 10, which would be equals to 20 Newton second or 20 kg per second, right? तो ये आपके पास चेंज इन मोमेंटम है। नाउ हम लोग एक और सिचुएशन पे आते हैं विच इज कॉल्ड रिबाउंड, वेरी इंपॉर्टेंट। आपके पास बहुत सारे क्वेश्चन ऐसे आते हैं जिसमें हमें रिबाउंड के बारे में देखना पड़ता है या रिबाउंड का केस फॉलो करना पड़ता है. रिबाउंड आर बाउंसिंग बैक, रिबाउंड आर बाउंसिंग बैक. सो व्हेन वी आर टॉकिंग अबाउट रिबाउंड एंड बाउंसिंग बैक, एक्चुअली आपके पास क्या हो रही है, वेलोसिटी रिवर्स हो रही है, डायरेक्शन रिवर्स हो रही है. सो फाइनल
Yeah.
वेलोसिटी इज टेकन एज नेगेटिव, फाइनल वेलोसिटी इज टेकन एज नेगेटिव.
Negative.
सो अब आप देखो, let's say the same body is there, 5 kg का body है. If it is traveling at a speed of 2 meter per second and it is rebound with the speed of 1 meter per second, तो अब आप मुझे ये बताइए कि if I want to find momentum, initial momentum, then its initial momentum is equals to 5 times 2, which is equals to 10
10.
न्यूटन सेकेंड. ठीक है, ऐसे ही है ना.
जी.
अब आप देखो, what will be the final momentum this way. Final momentum P final is actually equals to 2,
5
5 times 1, which is equals to 5 न्यूटन सेकेंड. लेकिन इसमें मैंने आपको बोला कि क्योंकि ये डायरेक्शन मोमेंटम की डायरेक्शन अपोजिट है, तो इट विल टेक नेगेटिव साइन. सो इट इज नेगेटिव 5 न्यूटन पर सेकेंड. सो व्हेन वी फाइंड चेंज इन मोमेंटम, ये देखो, चेंज इन मोमेंटम इज द इम्पल्स, it is mv minus mu. So this value is your -5, -10, so it becomes -15. So
15.
मैंने इसको एक simple solution दिया है कि don't get confused in this all, just take this negative m common. आपने m को common ले लिया तो your equation would become -m into v plus u, -m into v plus u. और simply क्योंकि आपके एग्जाम में negative sign does not have any importance, so m into v
V plus U.
plus u. So actually what did we do, कि when direction is not reversed, change in momentum is simply mv minus u, without with no reversal of direction, मोमेंटम चेंज आपका क्या है या इम्पल्स आपका क्या है, इम्पल्स इज m into v minus u. But in case of rebound, what do we have to do, rebound के केस में change in momentum is equals to m into v plus u. ये दो चीजें आपने याद रखनी है, वेरी इंपॉर्टेंट. ठीक है, क्लियर है.
Yes,
ओके
sir.
अब उसके बाद आपके पास न्यूटन सेकंड लॉ ऑफ मोशन आ जाता है. व्हेन वी टॉक अबाउट न्यूटन सेकंड लॉ ऑफ मोशन, दैट इज एक्चुअली F is equals to ma, but F is equals to ma can be written in terms of change of momentum. अब देखो, what is acceleration, acceleration is v minus u divided by t, ऐसे ही है ना.
Yes.
So
Yes,
when it
sir.
is v minus u divided by t, so just replacing these values, F is equals to m into a की जगह मैंने क्या कर दिया, v minus u divided by t कर दिया. So I will get F equals to mv minus mu divided by t, where mv minus mu आपका क्या है, isn't it change in momentum.
Yes, sir.
ठीक है, तो ये देखो, so F is equals to change in momentum divided by t. तो मैं यहाँ पे इसको ये लिख सकता हूँ कि actually your force is impulse divided by time. So this is another formula कि अगर आप फोर्स फाइंड करना चाह रहे हो तो यू हैव टू डिवाइड इम्पल्स विद फोर्स विद टाइम, और सिंपली इम्पल्स इज इक्वल्स टू फोर्स इनटू टाइम. दिस इज द इक्वेशन, इम्पल्स इज इक्वल्स टू फोर्स इनटू
Force into time.
टाइम. गॉट इट.
Yes, sir.
अच्छा, अब हम लोग आते हैं न्यूटन सेकंड लॉ ऑफ मोशन कैन बी स्टेटेड बाय दिस ऑल सिचुएशन. अब आप न्यूटन सेकंड लॉ ऑफ मोशन को यूं एक्सप्लेन कर सकते हैं कि द रिजल्टेंट फोर्स इज इक्वल टू द रेट ऑफ चेंज ऑफ मोमेंटम. रिजल्टेंट फोर्स इज इक्वल टू द रेट ऑफ चेंज ऑफ मोमेंटम.
Momentum.
ठीक है, ये बात याद रखनी है आपने. फिर मैंने आपको यहाँ पे ये बताया हुआ है कि इम्पल्स कैन बी कैलकुलेटेड इन डिफरेंट मेथड्स और डिफरेंट वेज. ठीक है, इम्पल्स कैन बी कैलकुलेटेड इन डिफरेंट सिचुएशंस एज अबव. तो पहले मैंने आपको बताया, द फर्स्ट सिचुएशन इज दिस वन, कंडीशन नंबर 1, दिस इज द इम्पल्स. इम्पल्स इज इक्वल टू डेल्टा पी इज इक्वल टू m इंटू वी माइनस यू. ठीक है, इसको आप लिख लीजिए. दिस इज द फर्स्ट इक्वेशन ऑफ इम्पल्स, इट इज m इंटू v minus u. Second impulse equation is this one, m into v
V plus U.
plus u. ठीक है, दो इक्वेशंस हो गई. तीसरी इक्वेशन आपके पास क्या है, दिस वन, इम्पल्स इज इक्वल टू f into t.
T.
So these are different cases जिससे आप इम्पल्स फाइंड कर सकते हो. इज दिस क्लियर टू.
Yes, sir.
ठीक है, अब आप देखो, अच्छा, आपके पास इसके बाद हमारे पास आ जाता है लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम, राइट? दिस इज आल्सो अ वेरी इंपॉर्टेंट टॉपिक, लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम।
Momentum.
ठीक है, लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम इज बेसिकली बेस्ड ऑन लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम। सो लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम इज के, या कैसे हो? वालेकुम सलाम, you forgot about your class time,
Yeah, sorry,
you were
my
sleeping.
phone was on silent, so I didn't realize.
Okay, no issue. We reached to this point, momentum or impulse. So sorry, conservation of momentum, just giving you a quick review. Yeah. We will be back on this momentum. ठीक है हसान?
जी सर.
ठीक है, या देखो, मोमेंटम, वी वर टॉकिंग अबाउट मोमेंटम. मोमेंटम इज बेसिकली प्रोडक्ट ऑफ mass and velocity. So its equation is p is equals to mv, and it is a vector quantity, and its formula is kg meter per second, or simply we will use Newton second, which is also equals to kg meter minus kg ms minus 1. Okay, and direction of momentum is the direction of velocity simply, right? And here I have explained that momentum does not only depend upon mass, it also depends upon velocity. So I have figured out one example, that initially body has 5000 kg, which is moving in the same direction, and velocity is 20 meter per second. So whose momentum would be greater? The mass, which is 5000. But if this 2000 kg is moving now with 20 meter per second, then its momentum would become more. So momentum is directly proportional to mass and velocity both, not only mass or not only velocity. Then we discussed that how do we consider change in momentum. So change in momentum is called impulse, right? What do we call it? Change in momentum is called impulse. Okay, so impulse is basically change in momentum. So change in momentum is equals to mv minus mu, I mean final momentum minus initial momentum. But this is when the body is not changing the direction, they are moving in the same direction. So I have figured out uh, that over here. Yes, this is what, sorry, this was sign convention, this point was sign convention, that moving towards right would give you positive sign, and moving towards left will give you negative sign. So keep this thing in your mind when we talk about change in momentum. If a body is, and if this is a ball of mass m, it is moving towards right with some speed, so its speed is changing only. Here its speed is 2 meter per second, here I sorted out it is 6. So change in momentum is just mv minus mu. Okay, now if the ball is rebound, this is very critical case, and most of the time student is trapped in this one. When the ball is rebound, don't get confused in any situation, just put this formula, that change in momentum is m into v plus u. What is that? M into v plus u, simply. Got it? So here I have written two different equations type relations, that when there is no reversal of direction, change in momentum m into v minus u, and when there is a change in momentum, it is m into v plus u. Okay, then I have Newton's second law. We were at this point when you have joined momentum. This acceleration is basically v minus u divided by t. So when it is v minus u divided by t, just put the value of acceleration in the equation, and you will get mv minus mu divided by t. And this will give you a detailed concept of impulse as well. That impulse is mv minus mu is impulse. Remember this thing, in case of rebound you will use mv plus mu divided by t. For example, if I consider that how much force is being applied by the ball which is being rebound, so I will use this equation mv plus mu divided by t. So आपके पास impulse क्या हुआ? Impulse is here force is impulse divided by time, or simply you can say that impulse is force into time. ठीक है? Is it clear to all of you? There are 7 situations which can be asked to you. Then we can state Newton's second law in terms of impulse. that rate of change of momentum is called resultant force. Okay, is it clear?
Yes, sir.
Okay, हसन रिवीजन हो गई बच्चे?
जी.
Okay, अब हम आते हैं लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम पे. For this situation, when I told you that what is law of conservation of momentum, this law states that for any system consists of two bodies, at least two bodies, not a single one. When two bodies collide with each other, they exert force over same period, which results in the change in momentum. From Newton's third law of motion, the object A exerts force on object B, then object B exerts a force equal and opposite to object A. This means that the change in momentum will be equal and opposite. So, although this is an extensive concept or enhanced concept, but when two bodies collide with each other, for example, here I would, yes, here I have figured it out that two bodies are there. This is before that, let me tell you what is the principle of conservation of momentum. The total momentum before collision, you have to memorize this or you have to hifz it, right? Total momentum before collision equals to total momentum after collision. Is this easy for you? Will you be able to memorize this one?
Yes, sir.
Okay.
Yes, sir.
ठीक है. अब mathematically, according to sign conventions, you have to keep the sign conventions with you when the motion of the two bodies in the same direction, right? When the motion of the two bodies in the same direction. So let's say I have one body, it is m1 and it is moving in this direction with u1, and then this is your m2, it is moving in this direction with u2, and after collision, or they collide, this is the before collision, right? This is before collision, and after collision, this m1 is moving with velocity v1 and this m2 is moving with velocity v2. Then I can say that this is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. This is actually the law of conservation of momentum, what I have stated over here. Got it?
Yes, sir.
ठीक है, ये याद रखना है. It is also to memorize. It is important to remember. Okay, now this is that diagram what I have shown to you. ठीक है, अब आपके पास होगा when the law of conservation of body is moving in opposite direction. Here it is m1 u1 minus m2 u2. Why? Because this body m2 is moving in the opposite direction. Then this is before collision, this one, right? And this part is for after collision. So it is m2 v2 minus m2 v2 minus m1 v1. So this is basically that situation which is being applied for law of conservation of momentum. For example, if I say that let's have the concept of collision over here. Suppose this body is of 2 kg and this body is of 4 kg, right? It is moving with a velocity of 2 meter per second, and this body is moving with a speed of 3 meter per second, right? In this way, and after collision, this body is moving with a speed of 1 meter per second. Then what would be the speed of this body? Okay, this can be asked to you. This is basically the question. So you will use simply m1 u1 minus m2 u2 equals m1 v1, or it's your choice. If you use the same one, m1 v1 plus m2 u2 is equals to m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. It doesn't have any problem, but just put the negative sign with those which are moving towards left. आपका blue is moving towards left before collision and red is moving towards left after collision. So I can say that it is 2 kg into u1 is 2 minus 4 times 3 is equals to, what is your m1? M1 is your 2 kg, and I told you that its velocity is 1. So as it is moving towards left, so I will take its negative sign, and then m2 is your 4 kg, and I have to find out what is v2, final velocity of this blue body. Okay, this blue one. तो अब आप calculations करिए. It would be 4 minus 12 is equals to minus 2 plus 4v2. So what will be the solution of this one? Minus 8 is equals to minus 2 plus 4v2. So how to finalize this one? It would be shifted on the right, on the left. So it would become minus 6 is equals to 4v2. So आपका आंसर क्या हो जाएगा? v2 will be equals to 1.5. It means that this body would continue moving this way with 1.5 meter per second. This negative sign tells me this thing. Is this clear to all of you?
Yes, sir.
Confirm?
जी.
Okay. Good. Now, collision. Basically, collision is basically a process in which forces are exchanged. What is a collision? Collision is a process to exchange the forces.
Forces.
Two bodies collide with each other, they exchange the force. So there are two types of collision mainly. One, elastic collision, right? Elastic collisions are those collisions in which momentum and kinetic energy both are conserved. Kinetic energy, not energy. Remember this word is very important. Momentum and kinetic energy both are conserved. They are called elastic collisions. What do they are called? They are called elastic,
Collisions.
right? Okay. And inelastic collisions, sorry, may I have to, yes, this was the heading of this. And the inelastic collisions are those in which only momentum is conserved but not kinetic energy. The kinetic energy is lost. So when kinetic energy is lost, they are called inelastic
Inelastic.
collisions. Okay, they are called inelastic collisions. Okay, is this clear?
Yes, sir.
Right. Then we have another type of collision which is called sticky collision, right? Sticky collision. Sticky collisions are those collisions in which both the bodies move with the same final speed. In which both the bodies move with same final speed. I mean they are attached with each other. What do? They attach with each other, right? The collision in which both bodies move with same final speed, they stick together. Actually, when they will be stick together, that time they have the final collision. Okay,
Yes, sir.
so yes, in sticky collision, this is the equation. I will figure this out. Equation for the finals, for example, if I have the momentum m1 u1 plus m2 u2 is equals to m1 v plus m2 v, because both are moving with the same speed. Okay,
Yes, sir.
so when they are moving the same speed, I can say that is v would be taken as common.
Yes.
Okay,
नीचे m1 plus m2 नहीं लिखना.
नहीं, इधर से अभी मैंने एक स्टेप और समझाना आपको. m1 u1 plus m2 u2 is equals to, take this v common, you will have m1 plus
m2.
m2. Now you can figure out this v, make this v a subject. So v will be equals to m1 u1 plus m2 u2 divided by m1 plus m2. Is this clear? देखो, I have figured out v from here, from this equation. I use the same one.
अच्छा
Is
अच्छा.
clear?
You multiplied the m1 plus m2 on the other side with v.
No. M1 and M2 are basically multiplied with v ना. देखो,
Yes.
ठीक है? They are being multiplied with v over here. तो when I want to make this v empty, तो क्या होगा?
They
M1
will
U1.
come on the denominator side.
Yes, very good. They will become on in the denominator. So ये आपके पास होगा M1 plus M2. Is it clear?
Yes, sir.
हाँ, ठीक है?
जी.
ये बात क्लियर है? यही है?
Yes, sir.
Good. Okay. Now, देखो, applications of momentum and principle. There are so many applications what we can find. के applications of law of conservation of momentum में, for example, we have the rocket propulsion of rocket. When the gases eject out with some momentum, their momentum is changed, and then rocket moves upward with the same momentum. Then explosions are there. In explosions, actually, the momentum change takes place. Before collision, its momentum is zero. Momentum of this ball is zero, but when it explodes, every segment has its own momentum, right? If the segments would have smaller mass, their speed would be greater. Here, this is small, so it is moving faster. This is big one, so it is moving slower. So remember this thing. So all these cases refer that momentum of the ball before collision is equal to momentum of all the fragments after collision. Is it clear?
Yes.
Yes, sir.
Yeah. Okay, is it clear now?
जी.
Okay, so this is the bullet. I mean the game of bullet, right? So what do you think? Why do we have a jerk in the opposite direction when we fire a bullet?
Action, reaction, like gases push it back.
Yeah, the bullet is moving forward, and as a result, it applies a force on this revolver or this pistol or this gun, and it moves in the backward direction. So if I say that its mass is 20 gram and it is moving with the speed of 150 meter per second, and this gun is of 2 kg, what would be the backward speed of this? So can we calculate that? Okay, let's do it. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Now before fire, everything is at rest, so it is 0. So after fire, M1 V1 minus M2 V2. They are moving in opposite direction.
Yes.
Okay. So one of them would be shifted left on the left side. So M1 V1 will become M2 V2. Now check this one out. M1 is your M1. Let's take this setup as 1 and this setup as 2. So mass of the gun is 2 kg and we want to find its velocity. Mass of the bullet is 20 gram. 20 gram divided by 1000, so it would be converted into kg, and its speed is 150. So please calculate this one.
एक साइड पे 3 हो गया है.
Okay, it would be
1.5.
30 divided by 100, so it is gone. So 0.3, ठीक है. So it is 0.3. तो आपके पास क्या हो गया? V1 is equals to 0.3 divided by 2. करना जरा सॉल्व. ये 1000 था बेसिकली.
0.0003.
Yes.
हाँ नहीं 2 है, सॉरी. 0.15.
0.15 meter per second. This will be the speed of the pistol in the opposite direction. Is this clear?
Yes, sir.
Okay, now momentum. Yeah, there are so many examples of this. Read this one out, this passage. If you get this one out, because uh, I have written all of that stuff which is required or which is being used in your uh, cars and vehicles due to seat belts and airbags. Yes, is this understandable? That when the brakes are applied, the momentum of the passenger and car changes. This causes the rate of change of momentum. According to Newton's law, this momentum change produces a force which causes destruction during the accident. Actually, during accident, the destruction happens or destruction takes place due to change in momentum. If you apply the brakes, you have to stop, and when you stop, it depends from which speed you have been stopped. So if your speed was more, then what will happen, the change in momentum will be greater. That's why remember one thing, that if the change in speed is yes, these are some sort of dummy exercises. So let's check this one out, why I have figured this out. I have put this in the notes due to some reason. The only method to minimize the impact it is to increase the time delay. That's why seat belts and airbags are used. Remember this thing. I mean, this seat belt and airbags, they do a very, helpful job for a person. This seat belt s- is basically your brakes. Secondly, the airbag reduces, sorry, it increases the time to hit the steering wheel, right? And that's why the passenger is safe to somehow. But if you're not wearing seat belt, this airbag will break your front bones, this all area. This is too dangerous then. But definitely we have to survive. Then this one is the rear seat. Check this one out. The method of fastening the seat belts, there are some actually postures which are shown to you to wear the to fasten the seat belt. So we have to fasten the seat belts in different ways. This is basically a person. This one, this is its uh, body. This is the person. This is the body. I think so. This is without seat belt. Maybe this is with. Oh no, this is also not with the seat belt. He has crossed the front one. Okay. Now here I think he has or she has fastened the seat belt and so on. So remember this thing. This why I put this in my notes, because this topic is related to physics, but we have an awareness that whenever we are going to drive, we have to fasten the seat belt. This is basically our life safety to somehow, right? So is this clear to both of you?
Yes, sir.
Do you have any question in this?
No.
Okay. What about you, Yaya? Do you have any question?
No, sir, no, no problem, no question.
Oh, great. Okay. In next lesson, inshallah, we will discuss about the questions of momentum. I have sent you all the sheets, and Hassan, you have basically purchased all the sheets which are from MH photocopier. Okay. So